Dr. Bhaskar, Assistant Professor, Department of Computer Science and Engineering, Anna University, Chennai. Area of specialization is software engineering and database system. Guided more than 12 research scholars, published more than 40 national and international papers. Is a reviewer and editorial board member in international journals.
Welcome to the UGC lecture series in computer science. In this series of lectures, we have been looking at a specific topic called software engineering. In software engineering, for today's session, we will be discussing on software testing. Most of the discussions of today will be on why exactly we require software testing. It will be on a question of why should we test, what should do the testing, or who should do the testing, what should we test. So, for considering this, I will take you from a common problem that you will answer as part of source code with which we will continue doing it. Say for example, if I am asking you to write a program in any of the programming language to find whether a given number is between 0, 100. So, understand my programming, any program to find whether a given number is between 0 and 100. Having written certain number of lines of code for this kind of a program, for our comfort we will give some test cases. Test cases are those for which there will be certain input with which we will test it and what is expected as an output. So, there will be an expectation column and what is actually got after programming. So, if I test for the given programming, say my program says it should be between 0 and 100. If I test for the given programming, say I will give an input of 50, the expected answer should say me whether it is between 0 and 100, it will say an answer of yes. And the program that we have run should also mention the same result of yes. So, thereby we are predicting the accuracy of the system. So, for doing this, is it comfortable that we do only with 50 or we should do more than that? So, first of all we may have to understand this. So, my range is between 0 to 100. So, if I am to give something between 0 and 100, can I test with different test cases starting from 0 to 100? That means I will have 101 test cases. So, that is not a better practice because I would have done a total number of lines of code, that is appropriate source code programming only between 2 to 5 lines for this program. For such a 2 to 5 line program, it is not appropriate that we test it with 100 test cases. And if you ask any of the experts who do a good programming and an optimized programming, they would suggest more than 40% of the time they spend is for testing. Why? Because there may be several problems that occur as part of the testing. At this juncture, I post up one more question which is very logical to this field of software testing, that is, how do you differentiate between the words error, mistake, bug, failure and fault. So, there are 5 different words which I am trying to mention here: error, mistake, bug, failure and fault. Are all these things common as part of testing? In order to identify these many number of values, I am just posing you the simple problem. Say with the problem that I have mentioned, to write a code and to test for the values between 0 and 100. So, I draw a line which mentions 0 to 100. So, as far as our logic is concerned, it is not possible to test for all the 101 test cases right from 0 to 100. So on such a case, what are the values that I can test? Maybe I get an understanding from the given problem. I have mentioned between 0, 100. So some people may have a doubt of whether between 0, 100 is inclusive of 0 and 100 or exclusive. So at this point, as my user says, I have to give a value from 1 and 99. So anything that is within 1 and 99, 1 and 99 alone inclusive and not 0 and 100, in such cases I am to start testing this program for a condition which satisfies only from 1 and 99. So on this juncture, I will consider this 1 and 99 as two test cases, and some value in between, any one value. Now that I am considering 50 as my test case, so this value can also be considered as a test case. Having given two different values 0 and 100 as part of the program, as part of the question, I will consider 0 and 100. I repeat, now my test cases are 0, 1, 50, 99 and 100. That means as part of a 2-line program or a maximum of 5-line program, I am writing 5 test cases. It does not mean in no way that for every line of programming that I write there should be a test case. It is not meant to be like that. So as part of this particular programming, I have considered and I have returned 5 test cases. Now these set of test cases I mention it to be boundary value analysis. As part of the problem that I have given, the range is between 0 to 100. So if I am to test well within the range, though it means 0, 1, 50, 99 and 100, in such a case I will consider this to be as boundary conditions. I mention all these values as boundary conditions. Further, some people might have a doubt, why don't we test some value which is very much less than the given range and more than the given range. As part of the programming, I would have used a symbol which is called modulo. So integer of something would have been declared, and inside the program I would have unknowingly used a modulo which might neglect the value of negative. So a minus will be negated because of this modulo and will get some positive values for any set of given inputs. So if such is the case, we will get for all negative numbers. The problem is actually with the source code. For all negative numbers, I will get some positive replies. So in those cases, how to identify it? So to understand those problems, I might even consider some value which is well less than the given range. So some value in the negative and some value more than what we have specified. So I consider the immediate predecessor value, that is -1, and an immediate successor value 101, and how does my system respond to those questions. In such cases, for a boundary value analysis, to my understanding, I will have 4n plus 1 number of test cases, where this n would be the number of variables that I have declared. Let us consider our program, where write a program to find whether the given number is between 0, 100, whether the given number. So it will be a number, so it will be one variable. So if I substitute that one variable out here, what I will get? A 4 into 1 plus 1, which is 5. Now we will have an understanding of what we have deployed: 0, 100, 1, 99 and 50. So, I will have 5 different test cases which is to test for my boundary value analysis. Further, if I continue drawing with the next set of values, say 0, 100, 1, 99, 50 is also done. What happens in case if I mention the immediate predecessor value? What is my immediate predecessor to 0 is -1. The immediate successor to 100 is 101. How does my system respond if it is -1 and 101? So, in such cases, whenever I write these test cases, so now that I will get 7 test cases out of this. Because of that, I am arriving at another test case, another testing scenario which is called robust testing, which will have 6n plus 1 number of test cases. Now, I substitute the value of n here. As part of this problem, it is a variable, so it will be 6 into 1 plus 1, which will be 7. Now, count how many test cases that we have derived here: 1, 2, 3, 4, 5, 6, 7. So, that is the result which I am trying to get. Now, we will consider one more simple problem, so that will clearly specify how we can arrive at these test cases. Everybody would have come across the problem of quadratic equation. The basic equation for a quadratic problem is given something like this: ax square plus bx plus c is equal to 0. So, we could not derive at this kind of equation any solution to x. So, if at all we wanted to come out with a solution for an x, it will be by a formula minus b plus or minus square root of b square minus 4ac by 2a. So, if I am specifying this also, it is no point that I mention minus b plus or minus divided by 2a. The entire of my problem lies only with b square minus 4ac. So, how am I to address with this b square minus 4ac? So, after understanding the logic of the programming, I will write b square minus 4ac if it is said to be less than 0, if it is said to be greater than 0, and if it is equal to 0. So, I am writing 3 different test cases. One to mention, case 1 will mention b square minus 4ac if it is less than 0, what is the result? Say if b square minus 4ac is less than 0, so I will get a negative value. If I present something negative out here, square root will consider those negative values as an imaginary component. Whereas, if the b square minus 4ac is said to be greater than 0, where I will get a positive value to the square root, by where I will get some real component. And if b square minus 4ac is said to be equal to 0, then I will get an equal component. So, these 3 are the basic understandings which I will get as part of the quadratic equation. One is called imaginary, the second one is real, and the third one would be equal. So, to understand how this problem would work, again I am writing the equation ax square plus bx plus c is equal to 0, of which I am dependent only on b square minus 4ac is equal to 0 or greater than 0 or less than 0. For such a problem, if I am asking you to continue writing the test cases, what happens in such a case, which we will have the discussion after the break. Welcome back after the break. Before the break, I was explaining about quadratic equation. So, to understand the testing component in the quadratic equation, we have identified b square minus 4ac is equal to 0, where I will get the value of roots to be equal, greater than 0 the value of roots to be real, and less than 0 it will be imaginary. If you ask me how many different test cases that we can write as part of this testing scenario, I will say a as one of my variable, b as my second variable, c as my third variable, and what will be the expected output as part of this logic, and what is that I get as part of coding. So, expected result from the coding and expected result as part of the logic. So, let us try to apply what we have seen. As part of boundary value analysis, I have said the number of test cases that I will be writing is 4n plus 1, where n is supposed to be your number of variables. So, if you consider for ax square plus bx plus c is equal to 0, where I have 3 variables, substitute n as 3, which will be 4 into 3 plus 1, which will be 13 test cases. And for robust testing, it will be 6n plus 1 again, 6 into 3 plus 1, which will be 19 test cases. So, what are those test cases? We will initially try to find it out from a simple problem. This problem we may have to map it with the previous problem that we have given. The previous problem I have mentioned saying, write a program where I have to find the number between 0, 100. Say in this problem also, all the values of a, b and c is varying between 0, 100, which is mentioned to be a state. So, what are my test cases now? Say what happens in the first case. If I am to write the conditions for boundary value analysis, for boundary value analysis I write my first test case as say 0, maintaining b and c values. So, as part of the previous program, what I have written is within the boundary I may have to specify certain test cases, that is 0, its immediate successor 1, some value in between for my comfort, and 99 and 100. So, this will be a simple test case variation only for the variable a, by maintaining the value of b and c well within the comfort zone. So, I maintain b and c well within the comfort zone, which I mention it as 50 and 50, and for 1 also I mention it as 50 and 50, and for all values like this I will maintain the same to be as 50 and 50. In such cases, what will be the expected output? So, we supply the same values to b square minus 4ac. In this case, b square will be pretty high, which will be 2500 minus 4 into a is 0 plus multiplied by c is 50. On multiplication, this component will entirely get neglected, it will become 0. So, b square is 50 square. Now, you take the square root, you will get a positive result, by where we confirm that the roots will be real. As a similar case, applying for this scenario, b square minus 4ac, 50 square minus 4 into 1 into 50, where again the roots will be real. So, you will get a positive value, the roots are again real, but the scenario slightly changes, 50 square minus 4 into 50 into 50. Now, that for this we will get a negative result, which means 50 square will be 2500, here again I have 50 square multiplied by 4. So, this dominates, so I will get a negative results, by where I will get an imaginary value here. Here again I will get for these two cases an imaginary value. So, kindly understand, this is primarily because of the logic of the programming which I am trying to apply. I have nowhere written a single number of source code, nowhere I have written the program for it. So, by means of the logic of the quadratic equation, I am able to write so many test cases, and I may have to validate with the source code whether I am getting the same results as part of output. So, after having done for these test cases, now that we will go for another test cases. So, as I have mentioned, for boundary value analysis we will be writing 13 test cases. When you have seen to the previous case, I have written 5 test cases. Now, I maintain the value of a and c and I vary the value of b alone. So B is fixed to 0 now, 1, 50, 99 and 100. So I maintain A and C to be 50. So what happens in such case? If I vary the value of B by fixing up A and C, my B square minus 4AC will be for 0 minus 4 into 50 into 50. So this will dominate, so this becomes imaginary now. How about this? Again imaginary. How about this? This is again imaginary, whereas when I consider this, this becomes real. So here is where I understand the flow of the programming. So when I vary A, B and C, initially I have considered varying A, I got 5 inputs, by varying B I have got 5 inputs, and finally if I vary C I will get another 5 input. So out of which I am generating 15. If I continue doing so, I will write from the beginning A, B, C, some expected output and the source code output. Say I have varied 0, 1, 50, 99, 100, 0, 1, 50, 99, 100, 0, 1, 50, 99 and 100. By fixing the value of B and C to be 50 for the first case, and by fixing the value of A and C for the second case, and by fixing the value of A and B for the third case. So this is what I have mentioned in the previous slide, where A carries 5 input, B carries 5 input and C carries 5 input. So totally I am getting 15 inputs. But then as part of boundary value analysis, I say it is 4 into n plus 1, which will be 4 into 3 variables out here, which is A, B and C plus 1. So it will be 12 plus 1, 13. But then I am getting 15 inputs for this testing state. How come this is possible? If you keenly look at the problem that I have defined again, I have tested 50, 50, 50 initially, by where I got some output, and I am testing it for the second state with the same input of 50, 50 and for the third state with the same input of 50, 50, 50. So this made me to do the job redundant. So we can avoid this state by eliminating these two inputs. So eliminate any two of the state, so that will be avoiding some of our time. So when I eliminate these two, how many inputs I get? So 15 minus 2, which will be 13. So now I get 13 boundary value analysis test cases. Further, when I switch to a robust case, where I have said for one variable condition, where if I had these many number of inputs, what are those test cases? For robust test case, I have said one predecessor and one successor value. So now if I apply the same logic to the problem of quadratic equation, A, B, C, expected output and source code output. I will start with writing minus 1, 0, 1, 50, 99 and 100, and for 101. So which will be 1, 2, 3, 4, 5, 6, 7. So A will carry 7 inputs, B will carry 7 again and C will carry 7 again, which will be 21, of which again we will try eliminating the 50, 50, 50, which laid common for all the three. So minus 2, which will take me to 19. Now if you keenly look at what I have given in the beginning, robust test case, robust testing takes up 6 into n plus 1 number of test cases. On applying n as 3, I will get 6 into 3 plus 1, which will be 19 test cases. Now you compare with this result, I will be getting 19 test cases. So now I hope you understand the importance of these test cases, writing test cases. I have mentioned you with two different testing. One is called boundary value testing, the other one is called robust testing. There is another part of testing which is called worst case testing. How many should be the number of test cases that I should actually test is all given with boundary conditions and robust testing. Whereas what happens when I am giving more than, say suppose I can even test with 2, 3, 4 some values like that, how many there should be a limit. So I will write for a worst case with 5 to the power n test cases. Now apply the same to the first condition that we have mentioned, 0 to 100, 5 to the power n will be, at the maximum we will write only 5 test cases. And for the second case of quadratic equation ax square plus bx plus c is equal to 0, we will write 5 power n where n is 3. So 5 power 3 which will be 125 test cases at the maximum a software testing engineer might write. But then as a worst case, if at all there occurs some problem, they might go for 125 test cases, or else given a limit of 0, 100, a software engineer who is trying to produce an optimized set of test cases will only write either 13 test cases or 19 test cases as part of boundary value analysis and robust testings are concerned. So far whatever we have discussed, we have considered only the black box, that is by understanding the programming how much we can generate the test cases, that is alone we have considered. So we might put all these as a black box testing. On looking at the source code, when we could derive certain test cases or certain results out of the same, we consider those as white box testing state or a transparent testing or a glass box testing. So any given testing scenario will carry two different set of testing states. One is on given a problem statement, if you could write your test cases, which will be called a black box testing. On given the source code, if you are generating certain test cases, which we will call it as white box testing. So now I will take you to some terminologies as part of this software testing is concerned. There may be syntax errors or misunderstanding of specification. So as and when we try to write the source code, it might lead to certain syntax errors. People who write programming in C, they might either put a flaw on putting a semicolon at the end to terminate a statement, or they might use, since C is case sensitive, they might drop it out with small p on the printf statement. So such cases we might have to neglect. Now let us look at the summary for this session. We have started with saying why do we need to do testing, and how about it when it comes to writing test cases. So by where we will try to understand what are my expected set of output as part of without writing a code and after having written a code. I have explained to you about boundary value analysis, a case of robust testing and worst case testing. Further, the questions for this session would be, again I repeat, why do we need testing? How do you differentiate between the words mistake, error, bug, defect and flaw? Is boundary value analysis and robust testing a part of black box or white box testing? You may have to say whether it belongs to a black box or a white box. Thank you.